So B, you should have written opposite sides are, what do those tick marks mean? Congruent. That is property B. Opposite sides are congruent. So if the top is 7, the bottom 7. If the left is 3.5, the right is 3.5. That's what congruent means. It means the same. What? The sides, congruent means the sides have the same length. Thank you. Very good. Same length. Megan, C. What do those markings mean? When I put an arc on 2 different angles, what does it mean about those 2 angles? They both have an arc. They are equal. So which angles are equal? Are all 4 angles equal? The diagonal. Okay, and there's another word. What word? Opposite. So opposite angles are congruent. Write it down. That's what is so funny. That's letter C.
Opposite what?
Opposite angles, Dimitri. Thank you for paying attention. Opposite angles are congruent. Oh boy. Julius, you're up. D. What? How are those numbers related? 120 and 60. Kendall, I didn't ask you. What do 120 and 60, what do those have to do with each other? Yeah. What word do we use for that Ashley said that starts with an S? And Brett said now. So which angles are supplementary? Are opposite angles supplementary? We used a word yesterday and it started with a C. Can anyone recall that word? It's not opposite. It's not corresponding. What? I think it was close. Consecutive. Matt got it. Ding, ding, ding. Oh, you might call it cards. Consecutive angles are supplementary. That's what that's called. Write it down. Consecutive. That means in a row. Consecutive angles are Consecutive angles are supplementary. Consecutive angles are supplementary. And Brett, E. What is E trying to tell you? First, hey, what is this called? Just tell me what that's called. It's not a side, it's a, not a hypotenuse because it's not a right triangle. Okay, it's a diagonal. Is that okay? So what is this diagonal doing to this diagonal? Crossing it, but
So is it saying that they're perpendicular?
they're not perpendicular.
Cutting in half.
Cutting in half. What's the word we use for that? Starts with a B. Poor Brett, you aren't even giving him a chance. The diagonals bisect each other. That is the last property. That means cut in half. The diagonals cut each other in half. If one diagonal is 10, when it gets cut in half, it's 5 and 5. The other diagonal is 20, gets cut in half, it's 10 and 10. The diagonals cut each other in half. Okay, you may gather your warm-ups. 5. A parallelogram has 5 properties. Thank you, I heard 4 louder. So, parallelograms. Ooh, look, that's a restaurant in the shape of a parallelogram. Isn't that cool? It's like overlooking the water. Can you see it? I don't remember where it is.
For a minute, I thought it was a boat.
I don't remember, but it's a restaurant. Here's someone who was bored and they folded their chip bag into a parallelogram. There's a bus lift. It happens to be in the shape of a parallelogram. And then there's a building with parallelograms all over it, so lots of fun. Okay, definition of a parallelogram. Property number 1. We already did this in our warm-ups, but let's write it on our family tree.
Where do you want us to write it?
In property number 1.
Oh.
Number 1 for a parallelogram. So what was property number 1? His definition. What do those symbols mean?
Parallel, opposite.
Opposite. So write that down. Opposite sides parallel. So this right here is what you are writing in blank number 1 on your family tree that you get to use all unit. So make sure you're writing to where you can read it and understand what you mean. So the opposite sides are parallel. What does it mean to be parallel? Same what? Not length.
Slope.
Slope. Sorry. Yes, same slope. Very good. So they are sloping the same amount. What's the slope of this line right here?
What?
Ashley? 0. So therefore, what has to be the slope of this one? 0. What's the slope of this one?
Don't know.
Estimate it.
Let's say
Positive or negative?
it's positive.
Positive.
2.
2. Sounds great. So if that has a slope of 2, then that has a slope of 2. Reminder, those are not lengths. That's not how long it is. That's how much it is sloping. Okay, next property. Write it down. Number 2, property dos. Opposite sides are the same exact length, no matter what. If they're not the same length, then it is not a parallelogram. It gets demoted back to a quadrilateral. Very good. Opposite sides are congruent. Congruent means they are the same exact length. Parallelogram. Moving on. Property 3. Opposite angles are perfectly congruent. True or false? If I give you one angle, you know all angles of a parallelogram. True or false? Opposite sides are congruent.
Wait, what? What'd you say?
True or false? I give you one angle,
Yes.
you know all angles.
Yes.
No.
Yes, you can.
Yes, because if they're correct, on one side has to be the same.
It equals 180, so you subtract.
Is it all
the
the
angles,
angles?
and that equals 80.
Oh, wait, you can. Because
What's the next property going to tell us? The next property, property 4, is going to tell us that consecutive angles are supplementary. What's the supplement of 25?
1.
He said.
I plead the fifth.
75.
55.
If that's 155, then what's that?
155.
Whoa! You know one angle, you know all angles. Cool. Y'all are fun. Consecutive angles are supplementary. If you don't like that word, you can pick a different word, like angles in a row are supplementary, or side-by-side angles are supplementary. But consecutive is the official word.
I like same thing.
Same side interior, okay. Use it. SSI. SSI angles are supplementary. That will work. That will work. What do I have behind this? I forgot. It says consecutive angles are angles that share a side. There you go. Like same side. Very good. Can I move on? Last property. What was it? What was that last property?
Diagonal positive.
Boom. There you go. The diagonals cut each other in half. Write it down because we're moving on. Uh-oh.
Opposite angles are congruent.
The diagonals cut each other in half. Bisect. So let's try it. Let's see if we can put these properties to use.
Like,
It
are we
will
about to do
work.
this whole page?
Yes, by the end of the unit, we will have done the whole
Okay, I
page.
thought we were about to do it like right now.
No, that will get bored, right? We need to change focus. We need to change course. Julius is like, yeah, I already am. Okay. So, example number 1. I'm actually not going to talk about that. Example number 1. Here we go. That's other side, guys.
What side?
You should be on the side that says quadrilateral notes.
Okay. Oh.
Example number 1. Well, good. That's for Monday. We'll have a head start on Monday. Every problem I give you, you're going to be using a property to solve it. Naisha, what property do you think we're going to use to solve this one? We're going to solve for x. R. So, did I give you the slope of the sides? No. So, opposite sides are, which one? Yes, yes. So, that's the property we're going to use, guys. Opposite sides are congruent. Melanie, one of those sides I'm not going to use. Which side is no good to me right now? What did you say first? 5x is no good to me because opposite sides are congruent. This side is opposite that side. He is not involved. Sometimes I'll look so like, oh, so I'm trying to get you like, oh. All right, so do it. Come on, set them equal. 6x minus 3 equals 4x plus 17. What was that? Flying chocolate? The only way you could mess this problem up is by trying to shove 5x into your equation somehow. 5x doesn't go in your equation, so don't try to force it. Ava, have you solved for x yet?
Call it.
What?
Call the liar.
That you were gonna eat it after he threw it.
Okay, Lewis C, have you solved for x yet? What do you do first to solve for x? No, don't look at Omar's. What do you do first to solve for x? Okay, what's the opposite of minus 3? Well, then let's do it. Come on. Plus 3. 17 plus 3, Lewis. 17 plus 3. Stop looking at Omar. 17 plus 3. No, 17 plus 3. 17. 18. 19. 20. Go get your calculator. Torin, next up.
You need to divide.
No, opposite of positive 4. Positive 4x.
And minus.
Minus 4x.
Oh
Oh my goodness.
I forgot about that part.
First period. 6 minus 4. 2. We should not need a calculator for this problem. 2. X equals 20.
Divided by 2.
X is 10. We did not need a calculator.
What?
Shouldn't have.
Awesome.
Matt, what's AB? No, what's AB? 57. All right. 60 minus 3 is 57. 60 minus 3. Jeanette, how long is AD? Uh-oh, it's not labeled. Oh, no.
Yeah, it is. Miss Hampton.
Okay, calm down.
Not for you.
Now it's your turn to calm down.
Not for you.
How long is AD?
Same.
57? Guys, all opposite sides are congruent. Opposite sides are congruent. No, this is 57, this is 57. What's this?
I said, oh.
5 times 10. Yes.
Oh.
You plug it in here, 5 times 10 is 50. Opposite sides are congruent, so 50, 50. Girls, girls. Can we move on? Move on.
I didn't even get it.
I didn't either.
You didn't get which part? Well, I have nothing to say for that. Omar, what should we do first on this one?
This one's 63.
B is 63. What a great answer. We are using one of our properties, and the property is opposite. Angles are congruent. So you take the angle and you put it in the opposite corner. Tori, what would you like to do next?
See here.
Subtract.
What did you?
No, not in your class, like in school in general.
Thank you, Tori. No, don't add them. Don't add them.
A is 117.
180 minus 63.
Mind blown.
Austin, angle C. Answer. Nope. Thank you. You know one angle, you know all angles. That's how it works. The opposite ones should be identical. The opposite ones should be identical. Can we move on? That one was too easy. Let's keep going. Next one, example 3. Okay, here's what it comes down to. Are you looking?
I am looking.
On example 3, Kenneth. What? On example 3, Kenneth. What? What do you mean what? I'm talking.
You're whispering, actually. It's like a mind game.
When you've got a problem like this, you've got 2 options. Just make the right choice. You either set them equal or you add them to equal 180. Make the right choice. Do you set them equal or do you add them to equal 180?
Set them. Add to equal 180.
Are those opposite angles or consecutive angles? They're consecutive angles. Same side angles, yeah. So they're supplementary. So this one equals this one. There's nothing to set it equal to. This one equals this one. There's nothing to set it equal to. These for sure add to equal 180. They are consecutive. They're not opposite. They are not opposite. John, 3x plus 10x. I mean, I said the answer. 3x plus 7x. 10x. Okay, John, 10x equals 180. What is x? Okay, John.
At least we're participating.
I'm trying to call people.
Hey, man.
But you're always like getting on us for not participating.
No, I'm getting on y'all for talking, not for not answering me, for talking while I'm talking. I never said you didn't answer me when I called your name. Okay? Ready, John? This is your turn now. Angle D.
No, that's okay. You can ask me.
No, go ahead. 3 times 18.
Oh, yeah.
3 times 18.
54.
54. If you know one angle, you know all angles. Kenneth, angle C. Tell me how much it is.
How did you get?
We plugged it in, plug it in. Glade commercial. Kenneth, we know this angle now. We know that this is 54, 54. Can you just tell me what this one is?
126.
Yeah,
Oh.
exactly right.
Moving on. Can I move on?
Yes.
Now's your chance. You gotta ask me if you don't get it. How did he get 126? Some people don't know where it came from.
You plug it into the 7, or you just add.
2 choices. Very good. Yes, you're right. 180 minus 54. Or take, this is your key. Unlock the door. Take 18 and plug it into 7. 7 times 18. I think the 180 route is a little bit easier. All right, here we go. Uh-oh. Now the diagonals are drawn. Are we going to be okay with this?
No.
Actually, I need more chocolate.
There was such a thing last semester called alternate interior angles. Let's use it. So I want everyone to look at the 18. This is a parallelogram. So we've got parallel sides. When you've got parallel sides, you can use alternate interior angles. 18, 18. Everyone mark your picture. 18, 18. Now do it with the 25. 25, 25. 25, 25. Alternate interior angles. 25, 25.
Oh, so we have all the angles basically. Not doing
Do we have all the angles?
No.
Hmm. 2? Like 2?
Oh, wait.
What does this whole angle and this whole angle, what happens with those?
49.
They add up to 180. Thank you, Matt. So if this whole, what's this whole angle? 43.
44.
43.
Thank you. That angle is 43. So this angle is supplementary with 43.
130.
What?
137.
Yeah, 137.
137. So there we go. And now you subtract 88. 137 minus 88. What Matt was saying? Yeah, 40. Now we know all the angles. Now we do. Look, alternate interior, 49, 49. Alternate interior, 88, 88. Now we know all the angles. Ooh, what about those interior angles? Like, can you find angle 1? You know how many degrees are in a triangle? How many degrees are in a triangle? 300? What?
180.
180. So take this triangle and find the missing angle. Come on. Paige, what'd you get? Add them up. 88 plus 25 minus 180. Perfect. That angle's 67. And then we remember something called, starts with a V, vertical angle, 67, 67. Woo, we're finding every single angle.
Why?
Kaylee, last angle. Right here, angle 2.
Damn, son.
113. 113, vertical angles 113. And that is how you find every angle of a parallelogram when the diagonals are drawn. Let's move
How
on.
much more is this?
It's okay, we're almost done. 6 examples. We're on 5 out of 6. 6 is the end. The end. Promise. Which property have we not used yet? Alea, which property have we not touched yet on your family tree? What's the last one?
Bisecting.
What bisecting?
Diagonal.
Diagonals bisect each other. That means that this diagonal cuts this one in half. If DB has been cut in half, two equal parts, then what's true about this?
They're both 18.
Very good. They're both 18. Yeah.
So then
So solve for x. Solve for x.
Look, 18 cut in half, they're both 18.
X is not 18, but that segment is 18, so solve for x. 18 equals 2x minus 6. You get to set them equal. You get to set them equal because the diagonal has been cut in half. 18 plus 6, 24. 24 divided by 2. 12. Yep. Catherine, give me an idea how we could solve for y. What should we do? No one else say it. Just hold it in. Subtract 6 from y. We're solving, now we're done with x. X is over. Now we want to solve for y. No. Torin?
30 equals,
What property are you using?
the opposite side.
Yeah! Opposite sides are congruent. If the opposite sides are congruent, congruent means equal. You are allowed to interchange those. So 5y minus 10 equals 30. Do it. Set it equal. Ashley, what do you get? Sure.
Can you put this on like y,
Y1 and Y2, sure.
What are we doing after
You
this?
can solve for x. What?
What are we doing after this?
You know, always. We do a little half sheet, you turn it in, and you're done.
You said the answer.
Hello. Yes, very good. Thank you, Ashley. Last one, because I know you're really struggling to finish these notes. Let's do it. Look, there's no solving for x.
Hooray!
Prove that ABCD. Oh, that's not ABCD. That's MNOP. Cool. MNOP. Prove that it's a parallelogram. So I hand you the shape. I say, hey, can you let me know if this is a parallelogram or not? How would you check?
Because it says it.
Check the properties. Dimitri, how long is MN? How long? Count. Use your finger. Count. 1, 2. Really? 1, 2, 3, 4, 5, 6, 7, 8, 9. Awesome. MN is 9. Let's check. How long is PO? How long is op? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, right now, I know that one pair of opposite sides are the same length. Because they're 9 and 9. How long are these? That's a little bit tougher, huh? We don't know how long those are. But we can find their slope, and we can do Pythagorean theorem if we wanted to. What's their slope? Up 2 over 2. What slope is that? That is the slope of 1. Very good. What's the slope of this? Up 2 over 2. What's the slope? 1. So, property, we already found that opposite sides were congruent because they both equaled 9. 9 equals 9. And then we know that opposite sides are
Look at dot M there.
parallel. Yeah, M kind of got a little off. I don't know how that happened. So a slope of 1 and a slope of 1. What else could we do to prove it's a parallelogram?
Sides are parallel.
Yeah, we did opposite sides parallel. We did opposite sides congruent.
Opposite angle.
Can't really find the measure of the angles, right?
The divider.
Do we really want to draw all the diagonals? I think we're good with those two.
Divide.
I think we're good. Let's be good with those two. Let's call it.